Got that, thank you.
Hang on, sorry, I'm running now.
Okay.
We are filming the new sound advert for Mizuno forgings. Pretty much sort of idea came when we saw David Llewellyn doing his R&D presentations in Atlanta this year. And we thought, well, if we could take that idea to the general public, then it was a pretty compelling story.
It's a very basic like-for-like test, literally a case of striking the three clubs in exactly the same way and listening to the sound they produced. We think, as to the research and development guys at Mizuno, that the sound that comes out of the Mizuno iron clearly demonstrates a kind of manufacturing superiority.
I was quite astonished to find out that the cheaper golf clubs that we're experimenting with sound incredibly different to the real thing. When I say incredibly different, one's very dull, the other sounds like a bell almost.
It sounds almost like it's a musical instrument, this one, whereas this one is just a piece of metal. So it kind of lasts almost the same amount. Well, this one doesn't last much.
The one that sounds flattened and then rolled and pressed. It's not easy.
So, okay, so it's actually not actually metal when they do it, it's not liquid. It's not really poured into.
First two are.
The other thing that was really important, especially to the team at Mizuno, was that the test was true, or at least that we gave each of the three clubs a fair chance.
The object of today is to really record the sound of these golf clubs as clean as possible. I'm not using any effects, filters, not enhancing the sound at all. What you see is what you get.
And it's important for the finished film that the hand movement that you make is virtually identical, and it's actually just a tiny little drum like this.
Yeah, this one is just
it's a good noise.
It's a fair test in terms of comparing the sound, whereas a lot of people would kind of believe that if you had two clubs exactly the same shape, that the forging and the caster would kind of sound the same, feel the same, and perform pretty much the same. So this experiment using sound as the barometer is pretty much a way of proving that that's a misconception.
The first one is the 52, which is a forged. It looks more like a blade. It's kind of a mid-cavity, right? Okay, so this is the 52. We'll do it again. Okay, and this is the 200, which is a forged cavity back. Full cavity forged. Sorry, that's a bit much.
So the 200 is a fairer test of forging versus casting. It might not look as nice, but it is a fairer test of the. So, if this is all about an experiment of sound, the 200 is the one you should use.
Once we've come out of a setup, I tend to take wild tracks. Wild tracks are additional recording that I record purely for sound. The camera isn't going, I can switch off lights and try and keep the noise level to a minimum.
What the sound does is it gives you an indication that there's a real material difference between a forging and a casting. I mean, yeah, obviously sound itself isn't going to get the ball on the green or closer to the hole, but what it does do is, if you've got this kind of really kind of pure sound you get when you hit a forged golf club, which is kind of, you get that nice kind of ding, the sound holds for a lot longer. It's a sign that the metal itself is much purer, it's got the kind of grain intact inside, and the kind of the feel as such and the feedback is a lot purer. With the cast golf club, obviously you've lost the grain, it's been melted, it's been reset. You might have some kind of small foreign bodies in there, you've got voids, you've got air, you've got all this kind of thing, so there's no grain left in the metal. It's been left to reset itself, so therefore you get a much kind of harder, sharper donk, almost like a kind of plasticky, hollow, tinny sound. It's proof of one being quality and the other one not being such high quality.